So again, we're going to identify the vertex. We're going to see a term called axis symmetry in a minute. I'll explain what that is. But we know what H, K, and A are from that activity, so let's go a little bit quicker. So first, if we wanted to plot something like y equals x squared with a table, right, with a table of values, all we'd have to do is pick values and recognize that these are all going to be just the squares of them. All right, if you pick a bunch of values for x, and to get the y values, you're simply just squaring it. So what you're noticing is this. So what I want you to realize is that with a parabola, when x changes by a little bit, y changes by more. That's the whole idea of a second order function. When it's second degree, the change in y is greater than the change in x. What's the change in x for all the coordinates I chose? How much does x change by every time? 1. Is that agreed, right? But look at y. Y changes by 1 sometimes, right? But then y changes by how much? And then? So the change is getting larger, isn't it? The change in y is getting larger, while x's change is continuing to change by 1. If you kept going here, if x changed by 1 again, you would have 16. By 1 again, you'd have 25. So these changes is plus 3, plus 5, plus 7, plus 9. So notice the change itself is going up by 2 every time. So y is increasing at an increasing rate. Okay, it's like double increasing when you think about it. It's going up, but it's going up faster than x is going up by every time. This goes up by 3, up by 5, up by 7, up by 9, where x only goes up by 1 every single time. Okay? All right. Now, if we look at negative x squared, right? If we look at negative x squared, all we know for A is that it opens down. Okay? Opens down. It opens down here. So if we were to graph these, and you did this already, so I'm not going to go into crazy detail. Parent function, and whoops. It should be much closer. Should still be on the origin. Okay? And obviously this is not done very well. So we have the parent function, and we have y equals negative x squared. Again, that's with no shifting involved at all, if you just had negative x squared. Oh, all right, so I graphed on the next one so you could see. All right, so what we notice is that when A is negative, the graph is concave down. Concave down is a term you're going to hear in calculus and pre-calculus a lot. So opens down is the same thing as concave down. All right, opens down means concave down. Next, we notice that if the value of A were a decimal, like 0.5, it got wider. Again, we notice that if A was a decimal here, the graph was wider. When A was a value like 2, the graph became narrower. Okay, recognizing that the blue here is my parent function for these. The blue is the parent function for both of these. Okay, this is narrower because the number is now 2. Well, what if it's negative 2? It's still narrower, but now it's opening down as a result. Okay, all these conclusions we've already drawn, so I'm not going and spending a lot of time on these slides, guys. So if something is not clear to you, raise your hand and ask. All right, I'm assuming because we did this stuff already that this is making sense, but if it's not, let me know. Here we recognize that when we have y minus 3, it shifts up because this is the k value. From this, k is equal to 3, and this is showing a vertical shift up of 3 units here. So in red, this is the graph that we're referring to right now. Then in the bottom, in yellow, we have a plus 4 here. Well, if there's a plus 4, we know it's going to shift down 4 units. Because if there's a plus 4, it means that k is negative 4 in this case. So it goes down 4 units. So again, we recognize that the k value indicates some sort of vertical shift. Nick, can you close that window like halfway? Thanks. Questions on the k value and what it means? How are you going to get even better at this tonight? How are you going to get even better at this? Practicing. Seriously, for this kind of a topic, it really helps so much to practice. As you do more and more of these, it's going to get easier and easier. The h value, as we recognized yesterday, or on Friday rather, has to do with the horizontal shift. When we have x plus 3, as seen in the red graph, we notice that the graph shifts left 3 units. Simply because from this part, we know that h is negative 3. That's why we have a negative 3 shift this way for the red graph. So here's the vertex, 3 units to the left of where it had started. And then after that, we see when we have x minus 4, we know that h is positive 4, so it shifts to the right 4 units, making the vertex appear at positive 4. All the things that we recognized when we did this with that activity the other day. So let's put this together. All right, so when we look at a graph such as this, right here, the quantity y minus 1 equals the quantity x minus 2 squared, what we recognize is that h is 2 and k is 1. H is 2 and k is 1. So as a result, here's the vertex over at 2, 1. So as you're seeing, this is really actually very easy if you know what each parameter does to the graph. If you don't, honestly, you're going to be a little bit lost, and you're probably just going to be a table of values, that's it. I want you to indicate the vertex. I want you to tell me if there's an A value that's affecting it. Here there's not, so you don't have to worry. Well, this is the vertex, so there's my new graph. It's just shifted over. You can absolutely expect multiple choice for stuff like this, where I give you a graph and I say, which of the 4 graphs is the graph of this? Right? So you have to look and say, okay, there's a vertical shift, a horizontal shift. Or I might say, if k is positive and h is negative, which of the 4 graphs could be the answer? Well, if k is positive, it means that you have a positive y value. If h were negative, you have a negative this value. So you would know to move over and then up and put a vertex somewhere. So maybe it would be this graph that looks like that. And then the other 4 choices would be in other quadrants, so you could rule them out right away. Okay, that's what the 4 other choices would be for the other A, B, C, D values. Okay, so start thinking about how you're going to be questioned on these. So let's go through an example of this, all right? And I want to talk about this term axis of symmetry in this example. So please first identify H and K. What's H? Negative 3, I agree, because we see we have a positive 3 there. Mike, what's K? Positive 2. Niall, therefore my vertex is what? Negative 3, 2. And remember HK, it's alphabetical. Right? HK is alphabetical. So, we've got this following vertex right here. That's one piece. What else do we want to write down? Yeah, and it opens down. It's not wider or narrower than the parent function. It's the same steepness as the parent function. Now, there's a term called axis of symmetry. Raise your hand if you've heard that before. Raise your hand if you could explain what it is. Do it.
It's like on the parabola where I think it's depending on whether the graph opens up or down, it's the highest or lowest point. That when you like put a line there, you can fold over the graph, and it's the same thing.
Very good. Good explanation. So you go to the highest or lowest point, the max or the min, and you put a line through it. And that would be able to allow you to fold the graph over or be symmetric, hence axis of symmetry. So here we go over 3 first, and we go up 2. So there's my coordinate. It's definitely going to open down. Right? We know that already. It will definitely open down. Now, what you can do is you can recognize that any point on one side of the parabola is the same as the other side. So see that dashed line I just drew there? That's the axis of symmetry. Kelly, what's the equation of a vertical line?
X equals?
Yeah, and what is the x coordinate it goes through?
Sorry?
Where does it go through on the x-axis? What's the number? X equals?
-3.
Good. So there's your axis of symmetry.
How did you find that?
Remember, vertical lines are always lines that say x equals some number. And what that number is where it intersects the axis.
No, I know. How did you find that axis of symmetry?
What do you mean find it?
Where is it?
So this is the vertex. Remember, you just
Oh,
always in
okay,
it. So
okay.
this graph is going to open like this, right?
Yeah. Alright.
So I just drew it on there, just to draw it. And then I asked Kelly to give me the equation for it. The equation of any axis of symmetry is always x equals h. Write that down. The axis of symmetry in vertex form is always x equals h. Always, always, always. All right, and you can recognize that. Look, h is -3. And we have x equals -3. So, why is it useful to have an axis of symmetry? Simply because we can pick points on one side and reflect them over the axis of symmetry on the other. So let's graph this one by picking points instead of looking at the x-intercepts. So, if the axis is at -3, what points are around -3? What's to the left and right of -3? What are the nearest integers? -4, -2. Well, I don't need to do both of those, because if I have one of them, I have the other. So what I'm going to do is I'm going to make a quick table here, and I'm going to use -2 and -1 as numbers for the right side of the parabola. I'm going to figure out the y-coordinates, I'm going to plot those two, and then I'm just going to reflect it over. So go ahead and either use a table of values in your calculator or just plug them in the equation in the original. Come up with what y is. Now, it might be useful to go to the original and solve for y, so add the 2 over. I think that would be useful to add 2 over. So I would write it like this. And type that in my calculator. Recognizing this is a negative sign, not a minus sign, and that you definitely need this parentheses here. If you're doing it by hand, plug in -2, that'll give you a 1, square it, then negate it, then add 2 to it. What do you get when you plug in a -2? What do you get when you plug in -2? 1. You're going to get a positive 1 there. Go ahead and check on your calculator, please. Type the equation right here that you see exactly as it is in y1. Press. You need to practice this because I can't emphasize enough on the test how many people forget things. Go to second, hit graph. After you've typed it in y1, press second and then hit graph. It should bring up a table of values for you. Now, if you want to, if you have anything in the other equations, you might want to clear them out. So either turn them off or just go ahead and just clear them for now. You know what I'm saying? So clear them for y3 as well. Okay, now go second table. Second table, paste. Make them negative numbers. Now, in your table, it probably goes by 1s by default. It probably goes by 1s by default along your x, or as Ben has it set up, this is the way I want it. Notice there's nothing there. Anybody remember how to do this? I taught you this once earlier in the year. How do you get no x values? How does it allow you to type in? Like I can press 2, enter, and it tells me the y value. Table settings. Everybody press second, and see the button window up here? Above it says table set. And you're going to look like this. Okay? You want this first one to be on S. Independent variable, change that to S. That allows you to ask of X value. So ask then auto, ask then auto. Good, you got it? Okay, so what that will do now, if you have it on ask and then auto on your table settings, go back, press second table, you should see an empty table now. Does anybody not see an empty table?
Yeah.
No? Ask auto. Oh, because
Oh, okay.
it'll give you the line. Yep, so go ahead, type in -2. Just press delete a bunch of times. Oh, you're not getting the line value? That's alright, you need the equation there for it to work, yeah. Is everybody getting +1 when they type in -2? Anybody not get +1? Let me see. Alright, so let's go to y equals. There you go. What's wrong with it? No. Yes. Okay. Now go back to your table. Second table.
It gets the-
It is positive 1.
it was-
All right, so you got positive 1 and we type in negative 1. You type in negative 1, you're going to get negative 2.
Yeah.
All right, so let's graph those points. Negative 2, positive 1. I go over 2, positive 1. There's that point right there. Negative 1, negative 2 is down here. So I can see the curvature. Look at the curvature of the graph. That's what we talked about when we looked at the y values. The y values are decreasing by a lot more than 1 increment now. The first one only went down by 1, but then after that it goes down by 3, and then more and more and more, etc. Now, what can I do with these two coordinates?
Fuck them over the other.
Yeah, flip them over. So literally go like this. Take this and draw it over here, 1 unit over. So draw yourself 1 unit, 2 units. So take this one, put it right here. Again, take this one, reflect it over this line and put it right here. So there's the reflection of the coordinate negative 2, comma 1. Then go and take this one down here, reflect it over to the next hash mark along your x-axis with the same y height. So that one would go right here. And as a result now, we can see the curvature of the graph. What kind, well, I shouldn't even say that. Oh yeah, what kind of x-intercepts might you have in this example? Might you have? One of two options. What kind of x-intercepts might you have? We didn't find them in this example, but look where they cut across. Decimals. So they might be irrational or rational, but there's a good chance you're going to have a decimal x-intercept here. So if you were to find the x-intercept of this, by setting y equal to 0, moving the 2 over, dividing by negative 1, square rooting, subtracting 3, you would get values that were somewhere between, it looks like, negative 1 and negative 2 for this x-intercept, right over here. And this x-intercept would be between negative 4 and negative 5. All right? So if you were to solve this for the x-intercepts, they would just be a little bit messy. There's a good chance they would be irrational because you're going to end up taking the square root of 2. All right? And I can preview that for you. Set this equal to 0. Move the 2 over. Divide by negative 1. And now you're going to have to square root it. So at this step, this is where you'd be able to recognize that your answer is going to be irrational. There's nothing wrong with that. So if you found the roots, you would need to estimate the decimal at the end of the problem. Remember, square root is an exact answer. So you'd have to estimate this at the end to see where your x-intercepts would lay. Those are your x-intercepts right there. They're definitely irrational. So do in your calculator negative 3 plus radical 2. Get a decimal. Negative 3 minus radical 2. Get a decimal. Those are the x-intercepts we just saw on the graph a minute ago. So, for this topic, because we're going to do more of another example, I want you to again reiterate. Vertex. Vertex. If you're going to use a table of values, use the axis of symmetry. If you're going to use the x-intercepts, you don't really need the axis of symmetry because they will be already symmetric there. Okay? Identify what A does, opening down or up. So when you're answering a question on the test, and it's a free response, or part 1 or part 2, not multiple choice, and I say graph the following, showing all work. This is what I mean. Is that clear? This is what showing all work means. Typing in your calculator, drawing the graph is not showing all work. Typing in the calculator and just telling me the roots and telling me the vertex from your calculator is not showing all work. I want to see something done, a table listed, some sort of values there. I might even make the last page of the test without the calculator for the last 2 graphs. You'll be able to use it on the other questions, and I think I'm going to give you a last page where you can't use the calculator. And I want to see how you can graph this without it. So be prepared to do that. Does that make sense? All right, so when you're home tonight and you're practicing this, tomorrow your problem sets are due, so by default, I'm assuming you're going to be doing this last section of the problem set here, and this homework is not due until Thursday for this one. So if you've already done your other problem set sections, maybe 7.2, 7.3, 7.4, you can focus on 7.5 problem set tonight. when you're doing this, you can definitely have your calculator to check, but do it all by hand, and then just graph it and check it that it's right. Okay? All right. Look at these three conditions. Condition A. Condition A. When the discriminant was positive, this is where you have to go back and think back to lesson 7.3. When the discriminant was positive, that's what I'm writing here, d greater than 0. When that quantity, b squared minus 4ac under the radical, when it's positive, you get 2 real roots. All right? See there's 2 real roots here? When the discriminant was negative, what kind of roots do you get?
Complex conjugate.
Yeah, those complex conjugates, the imaginary roots. You see the red there? Notice you don't see any roots because they are imaginary. So when the discriminant is negative, you get 0 roots, like we talked about. When the discriminant equaled 0, remember we got a real repeated root, we called it a double root? Well, that's right here. That's what a double root looks like on the graph. Let's write that down. Okay, a double root, or highlighted at least, it's right here actually, right here. Okay, this is a double root. It is tangent to the x-axis, meaning it touches it and then it retreats. It touches once on the x-axis and it retreats. It could be on the bottom, it could be like this. Hit the x-axis and then come back down. It could be over here. Hit the x-axis, come back down. That's when the discriminant equals 0. Hint, multiple choice kind of problem. For the following function, negative x squared plus this, determine the discriminant, and as a result, determine the type of roots and which graph would be a possible graph. So say the discriminant comes out to be negative, you need to look for a graph that doesn't have any x-intercepts. If you get a discriminant that is positive, you need to look for a graph that has 2 x-intercepts. If you get a discriminant that's 0, you need to look for the graph choice that is tangent to the x-axis. Is that clear? Okay, this is relating section 7.3 with the beginning of graphing. Now, remember that to find a discriminant, though, your function needs to look like this. Something where you have it in standard form, where it's ax squared plus bx plus c. Okay, so this is not going to be given in vertex form. You'll be given a function like this in standard form, and based on this function, it'll say, determine the type of roots or which graph could be a possible solution for this one. Now, obviously, for something like this, I might make it where, well, I mean, I guess you could graph in your calculator. I might make this a multiple choice at the end of the test instead of the beginning where it's non-calculator, because anybody could just graph this and then figure out which graph it was, right? So this would be a non-calculator kind of question toward the end of your test. Okay, because we literally have, so for one like this where it says, find an equation in the form y minus k equals a times the quantity x minus h squared if the parabola has a vertex of 2, negative 4 and has a point 514. So in this problem, I'm telling you the vertex and I'm giving you a point and I'm asking you to come up with the equation. So if I know the vertex, what can I do automatically? Substitute for h and k. Plug them in. So let's go ahead. What was k in this problem? Look at the vertex. Remember, this it's always h comma k. What's k? Luca? Negative 4. And what's h in this problem going to be? Simply? 2. So I know this already. Again, I know it's going to be y minus k, x minus h, that's squared. Now, obviously I'm not going to write minus negative 4, so let's write it so that it makes more sense. How do I find out what a is? How do I find out what a is in this problem? What piece of information have I used this? What have I not used?
Coordinate 514.
Yeah, so what might you do with that coordinate?
Well, you know it opens up because when you plot it, it has to be mirrored.
Okay, so Ryan's already saying like, all right, I'm at 2, negative 4, and I'm going to 514, so it's definitely going to open up. Absolutely. It's going to open up, but exactly how do I find out A? If this point is on the curve, it should satisfy the equation, shouldn't it? So what can I do?
Plug in x and y.
Plug in 514 for x and y. 5, 14. Is that a point? And then determine what A is by solving for A. So let's plug in 5, 14. 14 is Y. 5 is X. So I've plugged in 5 and 14 there, and now I just need to solve for A, which is simple. 18 equals A times 3 squared. What's 3 squared? So we get 18 equals A times 9, so A is equal to 2. As a result, my final answer, I take this line right up here, and I write it again, but with the A value. So rewrite your final answer as Y plus 4 equals 2 times X minus 2 squared. This is my final answer at the end. All right, please, folks, your homework tonight. This is not due until when you have the test on Thursday. Tomorrow we will review. Tomorrow morning are office hours. Okay, I expect to see some of you here tomorrow morning. Remembering that you need to go over the other stuff as well. 7.2, 7.3, 7.4, 7.5. Okay, expect to have part of the test without a calculator. So practice this stuff tonight without a calculator and then check your work.